Hello and welcome to today's webinar, Nastran In-CAD. This webinar is brought to you by Live Lab Learning, which is a subsidiary of Academic Corporation, a wholly owned applied software company created to provide world-class training. This is Marcia Tucker and I'm delighted to be your moderator today. Throughout our presentation, we encourage you to interact with us by typing in questions and comments using the questions pane. We'll be answering those questions at the end of the presentation. This webinar is being recorded and you will receive via email a link to the recording. Regarding our Live Lab Learning, we invite you to visit this website so that you can acquaint yourself with our live virtual training classes in your specific area of expertise. We also want to make you aware of some upcoming events. We have a first look event in 2 locations currently. In June 16th, it'll be in Jacksonville, Florida, and on the 17th will be in Savannah. This is about what is happening with the Autodesk 2016 release. We'll also have a happy hour. And for more detailed information, you can quickly scan this slide, but please call me. My number will be later in the slides, but this is big for applied software to go on the road and take our technicians and staff to on-site. We certainly invite you to attend and share the news with your colleagues. We have another big event. There are only 1 of 8 of these taking place in the United States, and this event is hosted at the Woodruff Art Center here in Atlanta on Tuesday, June the 23rd, from 1 to 4 p.m. Autodesk leadership will be speaking as well as making you aware of trends that are facing manufacturers so you can remain competitive and gain market share. My contact information is below in red, and my direct number is 404-564-1870. We also have upcoming webinars. We have Inventor HSM, which is your CAD/CAM software. That is June the 16th, and on the 23rd, we want you to be well aware of the benefits of being on maintenance subscription and the new Autodesk account. That's a new portal and gives you a tremendous amount of tools that you can use quickly and easily. Then on July 14th, we will be reviewing Simulation CFD, and you can register via our website for that. Now for today, I want you to be aware of Jason Miles. He is our presenter today. He is degreed in Industrial Drafting and Design plus Computer Information Systems. He interned at Thomasville Furniture, which led to him being a project engineer after graduation. After holding several positions, he was promoted to the parent company, Furniture Brands International, as their digital design specialist. Currently, Applied Software, we are pleased that Jason works for us as a senior application specialist with responsibility for Autodesk manufacturing solutions. So Jason, if you would educate us about Nastran In-CAD 2016, that'd be great.
All right, thank you, Marcia. So the first thing that I want to do is the people that is not familiar with the Nastran In-CAD, I want to
Jason, we are not able to hear you.
hear me.
Hello, Jason?
Yes.
All right, there I could heard you say yes. You might want to start.
Can you hear me now?
We can hear you now. You might want to start on the very beginning. Thank you.
Okay. Okay, sorry about that. What I want to do today is the people that hasn't heard or know of what Nastran In-CAD is, I want to give a brief introduction of what this software is. So the Nastran, it's a general purpose finite element analysis tool embedded in your CAD system, and it is powered by the Autodesk Nastran solver and offers simulation spanning across multiple analysis types.
I apologize. We are having technical difficulties with Jason's audio. Jason? Hello?
Yes, can you hear me?
Can hear you now.
Okay, let me double check something real quick.
In the meantime, while he's checking on that, this product is a phenomenal product. It is going to be able to provide your simulation and stress analysis with a proven solver. I mean, the solver, and the reason why it's called Nastran, it was developed years ago for NASA. So it has incredible credentials behind it, and you can depend on the results you get as being accurate and thorough. Let's see if we can hear Jason now. Are you there, hon? Hello, Jason?
Brianna, can you hear me?
I could hear you say that.
Okay.
But I don't know if she can hear you.
Okay.
Jason, you're loud and clear currently.
Pick up where you on this slide, please.
Am I loud and clear?
Loud and clear.
Okay. It might just be on your end, Marcia.
Well, I hope so, yeah.
Okay. All right. So, like I was saying, this is a tool and heat transfer. Is and serves multiple CAD platforms, providing a consistent user experience and eliminating the need for multiple single platform simulation technologies. Also, the great thing about it being a CAD embedded product, it actually streamlines processes, helping you to maintain your productivity and eliminate compatibility issues while equipping you with an industry-recognized professional-level FEA platform. Autodesk Nastran In-CAD delivers powerful FEA technology while keeping the familiarity, ease of use, integration, and associativity of your existing CAD system. One thing that I'd like to point out, if you are a user, is embedded in that software. Another thing that I'd like to point out is the basic analysis capabilities of Nastran. We have such analysis types such as linear statics, buckling, normal modes, pre-stress static and normal modes, linear steady state heat transfer, composites, assembly modeling with contact, and thermal stress. But in addition to the basic analysis capabilities, we also have some advanced capabilities where we can get into the nonlinear statics, nonlinear transient heat transfer, nonlinear steady state heat transfer, random response, frequency response, linear and non-transient response. Then we have some advanced nonlinear and hyperelastic materials, and then also some automated impact analysis and drop tests. So with that being said, for the people that are familiar with Nastran In-CAD, I want to spend a little bit of time on talking about what is new in the 2016 release. So let's start out with the moment loads and solid element faces. So the moment load now allows you to define on solid element faces. You can apply a face moment on solid element models by selecting a face and entering the magnitude based on the axis of rotation. Also, in regards to the remote force, which is a force that is originated from a point in space, not on a model, you can apply a remote force like you apply force on the model. You can select surfaces to apply a remote force. Regardless of the surface selected, the remote force will be distributed to all its nodes. The automatic contacts get generated, which takes the geometry contact given in the model tree from Inventor, and it displays the names of the bodies for a much easier understanding of which parts are in contact. This detects the contacts within the tolerance specified in the analysis dialog and the geometry contact set in the model tree. We also have some improvements in regards to the meshing progress bar. Now it shows the progress of the surface mesh and the volume mesh, and also the overall progress of the meshing. So we get a nice visual showing us whenever the meshing is being applied. Improvements have also been made to the XY plot. So in this release, plotting the results with respect to nodal/element distance are now based on coordinate distance with respect to the position selected. You can now filter your results by either selecting nodes or elements. Also, selection filters are added at all of these selected entities selection box. So when you right-click at the selection box, you'll notice select faces, select edges, and select vertices are listed. So this will just make sure that you are setting and selecting only filtered faces, edges, and vertices. Also, with the release of Service Pack 1, you will notice that the Nastran tab has been moved to the Environment tab. And also with this Service Pack 1, we also have some improved performance. Results probing has been added to the ribbon, and this will become active. You'll notice that whenever you first go into your model, if you don't have the results already loaded, that it will be grayed out. So once the results are loaded, it will then become active, so you can go around and probe different areas of your model to see the different results. Also, on previously solved models. So to enable this, the only thing you need to do is go to the default settings underneath post-processing and just make sure that automatically load results is checked. Also, within regards to the units, easy access of units to define for the analysis at the browser. So you can double-click the units button in the browser tree. Now default, that actually takes the units that are set from the CAD system. And then you also have the option to go in and override any of these settings. Another nice little addition that they've made is they've updated the terminology to be more consistent with Inventor. And you'll notice that even when you hover over one of these, say like any of this terminology, you will actually see that a little pop-up will show the actual Nastran terminology. Now this is a great thing here. The material database of Autodesk Inventor will automatically get loaded whenever you're selecting a material. Also, if you have some custom libraries that you have set up, you can actually import those as well, whether it be an XML or an SLDMAT file. You can load those to utilize in Nastran. Another thing that they've done is they've enhanced, or some enhancements have been made to the factor of safety template. So now the scale is automatically reversed to show the lowest factor of safety in red. Now with those new additions made to the 2016 release, what I'd like to do now is actually jump in to Inventor, and let's go through and set up a model in Nastran, and let's see some of the results and the ease of use that Nastran gives us. Now you'll notice that I have a hedge trimmer, but today what I want to focus on is actually the guard here. And this guard is actually made of a thin plastic, and typical load conditions on the part can cause a large amount of displacement. So what we're going to end up doing is I'm actually going to perform a non-linear static study so that we can get some high fidelity results. Now you'll notice that I'm still in Inventor. We have a Nastran ribbon up at the top. So the first thing that I want to do is I want to start a new analysis. And I'm just going to go ahead and give it a name. And you'll notice that I want to choose the type of analysis we're going to perform. And you'll notice that we have a lot of different types that we can choose from. But for this one, we're going to choose nonlinear static. Okay, and then I'm actually going to set up a material, and I'm actually going to select this material from the Autodesk Material Library. And for this particular one, I'm going to choose a ABS plastic here. Okay, let's cancel this just for a second. Guard, static, okay. And let's try this again. Let's see if it's going to let me edit this. There we go. So we got a nonlinear static. Next, I want to choose my material. Okay, and if I wanted to rename this so we don't have that long name here, I'll just abbreviate it. Okay, and you'll notice in my browser, we have our model and our model tree here. Let's go through this. Okay, there we have it. Then next, I want to go to my physical properties. This is where I want to assign that ABS plastic here to my associated geometry. So you notice just my guard. And then also, let's go in here and make sure everything's selected. Okay, all that's set up. And then also, let's go in and edit this here. Actually, for this one, I want to run a specific nonlinear material data, so I can go here and set the type as plastic. Let's say for this one that I know that this material yield point is 40 megapascals. And I'm just going to use a simple 2-point curve And then what I can do here, let's say I'm going to use the two-point curve to define the behavior of the material, and then I can take a look at this two-point curve, and I can notice that the material softens greatly after it reaches its yield point. Okay, once we have all that set up, the next thing that I would want to do is maybe I want to control some of the mesh on the element size. So I'm just going to go ahead and set this to 6. And then also, the real power of the nonlinear analysis solver is actually, we can take a look at the setup here. And what I can do is define the number of iterations. So what this does is the solver will apply whenever I go in and set up some constraints and loads. It will actually, and I'm going to apply, let's say, so we have a real world scenario. Where this guard mounts to the trimmer, I'm going to go ahead and fix the bottom here. So we have those two fixed, and then I want to add a load going to the front of this guard at negative, let's say, 333 newtons. That's going to be somewhere around 75 pounds. Okay. Now, once we have those set up, for the sake of time, I've already ran this, so I'm going to go ahead and load my results. So let's finish this one here. I'm just going to open up the guard. Okay, we'll notice the loads that I've set up, I have them actually showing visibly here on this model. And let's go in and let's see what we can do here. So I ran it at 25 increments. So you can notice I can go through on any of those increments to see how the model is being affected. So I'm going to go ahead and go to increment 25. And I'm going to turn off some of the visibility here. Now, one thing that I can do is I can actually show the displacement, and you'll note the deformation scale is 10% more. So if I display that, you can see right now that I'm seeing my max, and it's over what my yield point needed to be. So we're at 43. Also, I have the capability of animating this. All right, let's stop this here and let's look at some of the von Mises stresses here. All right, so we can see where we have some of the high stress out here. Now, if I wanted to, I could come in here and specify the min and max. Maybe I wanted to see where the min was of 40. And let's display that. So you'll notice we got a min of 40 down here, but also we still see that more of a highlighted area where the max is. Let's try this animation again here. All right, let's take this off. Looks like I'm having a little bit of difficulties here. It's not showing the animation. But let's go ahead and continue here. And so let's think about this. So I'm over my setting that I initially set up for 40 on the yield. So let's say, what could we do to fix this? So possibly I could go in and modify the ribs. Maybe I could change the material, or maybe the overall thickness of the part in general. But for this particular one, what I ended up doing was actually going into this model and changing the degree of this rib. So for instance, it was 40. And let's go ahead and close out of this one. And let's close out of this one as well. Okay, you'll notice here, just as if I would finish the Autodesk Nastran In-CAD, go back to my model. And for this one, let's go ahead and take a look at the sketch that I actually modified. So it's for the large ribs. And this on the initial analysis was 40, and I changed it to 50. And you'll notice that the ribs became a little bit longer. So let's go ahead back into our Nastran. Let's close out of this. Give it a second to load. There we go. All right. So here, let's go ahead and I'm going to set this as active. And let's see the results that we have here. If I go down to my increment of 25, I'm going to see right now that I'm already underneath my yield. So let's see what we have. And let's turn off some of these so we can get a better representation. I'm going to turn this off. So you notice now our max is 31.89. Just by changing the angle of my rib, made it a little bit stronger here with the 75 pounds or 333 load coming in on the front. Okay. And then I also have the option, if I want to come in here and maybe probe at certain areas, I can do that as well. Let's go ahead and I'm going to try something here. There we go. That might have been the reason there. So let's go back here and try this again, because I really want to see that animation, because I can take that animation and then I can actually export it out as some kind of AVI or some that you can play through your video player. Well, it looks like not today. All right. So let's try something here because I really want everyone to see that. There we go. That's starting to look a little bit better. All right. Let's hide all these. Looks like I'm having some technical difficulties, but we got to where we wanted to see the different, the min and max by making a, there we go. So we can see here with this animation, as it's going through each increment, you can see where the stress is because I'm showing the results of the von Mises stress as that load is being applied. So this can give us some good data on possibly some of the design changes that I might need to make, maybe play around with different materials or different thicknesses. I could have possibly actually just thickened maybe these ribs in here, but it's stuff that this software gives us capability of going through and testing. So with that being said, I want to go ahead and turn it back over to Marcia.
Yes, thank you, Jason. If anyone has any questions, please feel free to type them in the window pane. And we do have a question. Why do dialog boxes come up halfway off the screen every time? And is there a way to change this? Change the default placement when you were doing a demo?
Yes, that one actually is because I'm using dual monitors. So I've noticed that it's actually, it'll snap to the center of those, and there is not a setting to change that. So if it was just because I'm running dual monitors.
Okay. Hopefully that will, Harris, if you have any additional questions pertaining to that. All right. I don't see any other questions. So we do appreciate everyone's attendance. We know that your time is valuable, and we appreciate you spending with us. Again, there is our Live Lab Learning website. We also would invite you to visit our YouTube channel, and this will be where the webinar will be recorded as well. Okay, we do have another question that came in. Just a minute here. Let me see. Okay, how does Nastran compare to simulation? Well,
now are we talking about Inventor simulation or?
Yeah, we need a little bit more definition of the word, just simulation. We don't know if you're, he wants to know about Inventor. So, well, how I would answer that, and I'll ask Jason to contribute to that, John. Inventor Pro simulation is a great place to start, but the next step up is when you step into Nastran, and that many times you'll hit a wall in Inventor Pro, but what you don't know is that you hit the wall. Nastran will uncover that because it does nonlinear simulation where Inventor Pro just does linear. Jason, you want to tie in and add on to that? I'm sure your depth of knowledge is greater.
So with Inventor, you can do static stress, natural frequency, modal, and you can do modal with load stiffening. So the slide that I showed earlier, some of the key things that Inventor can't do is like response spectrum, random vibration, frequency response, transient stress, also critical buckling, and then also with you can perform nonlinear analysis within Nastran. So those are the key differences.
Right, and then if and Nastran will do 85 to 90% of simulation. Not real sure what your product is that you manufacture, but if you oftentimes simulation CFD or FEA is when you really have a research R&D department, and the guys are in the little white coats too. So Colin wants to know, what about the quality of results of static stress analysis between these two products?
Just the static stress, and those are pretty much the same, since Inventor and Nastran can perform both of those. It's the same. We really get the powerfulness of the tool by doing like the thermal studies and also the nonlinear studies.
Right. Yes. Now, also, Nastran solver is not the same solver that is used in, or is it? It is the same solver, isn't it, as Inventor?
No, it's a different.
No, they're different solvers. Yeah. Okay.
Right.
Okay. All righty. Great questions, gentlemen, for sure. Okay. And again, we thank you for your time, and you'll be getting an email from us that will provide several things. One, it will provide the link for this recording, and in addition to it, we'll also provide you the link for the upcoming webinar, so you can join us in those as well. And please let us know how do you. Yeah, I think we're good on the recording after that initial part. So, all righty. Thanks so much, and have a blessed day.